Hi, I'm Anika Patka, and this is my Lab 1 report for Physics 1. This lab had four main parts. To start, I recorded a video from which I obtained our tracker data. From here, I altered a GlowScript code which led to the creation of my model and predicted data. Then I was able to compare my data and my model, which led to my answering of the discussion questions. Additionally, this lab focused on two main principles: Newton's first law and Newton's second law. Newton's first law is stating that an object in motion will stay in motion unless acted upon by an outside forcing. The second law, however, is the momentum principle, which notes that the presence of a constant speed means the net force must be zero. We'll go into this more later in my GlowScript code. Additionally, I wanted to mention that while this lab seems relatively simple, it's actually very applicable to our everyday lives. For example, transportation systems rely heavily on both forces and accelerations. But let's move on to my video and tracker data. To obtain my data, I only ended up using about a sixth of the original video. I didn't want to use the start of the video because the original push force was in effect, but I also didn't want to use the end of the video because the ball would have been slowing to friction. Essentially, I only ended up getting about 14 points from less than a half of a second of video. In my attached data, one can clearly see the short time length of the frames from which I obtained my data. I also wanted to note that displacement in the Y is not important to the scope of this lab, and while it changes, this is due to the perspective of the camera, not due to an actual change. To the left, I have included my GlowScript model and the data obtained. The right half of this slide, however, notes the changes in code that I made to obtain this model. While I'll be explaining my derivation process for both the items in blue and the bolded code on the bottom of the slide, I also wanted to note two important changes. I changed the time step to the given value because this was the length of a frame for my experimental data. This would allow the two data sets to be more easily compared. Additionally, I changed the net force to be zero in order to maintain a constant speed. This is due to Newton's second law, which states that in order for an object to be at a constant speed, the net force must be zero. To obtain my position vector and my velocity vector, I use data from Tracker. I also want to note that my velocity vector assumes that the first two data points give the constant speed for the entire 14 frames. I don't know this for sure, but it is an assumption I have to make to have a model of constant speed. I have also attached my derivation process for both the ball position equation and the ball velocity equation. To start with the ball position, I took the average velocity formula and expanded it to get a velocity final is equal to the initial velocity plus the average velocity times the change in time. To find my ball velocity equation, I simply divided my ball position equation by t. To update these codes in GlowScript, I simply replace the typical physics variables with the variables pre-designated in GlowScript. Finally, we get to the comparison between my experimental data and my GlowScript model. I'm very happy with how the two compare, but I also want to note that the discrepancy between the two sets of data is due to the presence of friction. This shows that while we want to assume we have a constant velocity, there are still forces acting upon the object. This lab also asks what would happen if I were to change my axes. Essentially, speed would remain the same because it's directionless, while the velocity vector would change. In the attached graphs, you can see that the rate of change is the same, while the direction is different. The second question this lab asks relates to the overall meaning of the lab. In particular, I think it's important to note that it's not possible using Tracker with this simple video to quantify all of the forces acting on the ball. While this lab focuses on forces in motion in just the x direction, it's also important to note that there are also forces in other directions on this object, such as the normal force and the gravitational force. In conclusion, this lab gave me a lot of perspective on constant speed. I've noted a few ways I would like to improve upon future experiments with constant speed, but also wanted to note that this lab really opened my eyes to the amount of forces that act upon motion every day in my life.